So now we got 1.2.1, we got equations still, but we're bringing in parentheses. So things are going to get a little more exciting. So what do we do with parentheses? Well, look at this image that I have here. You distribute. 4 times x is 4x. 4 times 3 is 12. That's all we're doing. From there, combine like terms and solve like you normally would. So let's take a look at this first example. I'm going to do the examples from the left side. The right side will be left for the class. So let's look at the first one. So let's start with distributing. So I'm going to distribute this 2. 2 times 5 is 10. 2 times negative d is negative 2d. So I have 10 minus 2d. On the other side, we have 2 minus 4d. Now it looks just like what we've been doing in class. I'm going to go ahead and just move this 4d to the other side. Remember, it's negative, so I'm going to add it to both sides. So we'll have 10, and then negative 2 plus 4 is positive 2. 10 plus 2d equals 2. Now I'm going to subtract this 10 to the other side. So I'll have 2d equals negative 8. And then I'm going to divide the 2. And d equals negative 4. Not too bad. So what I want to show you is one where we have to combine like terms. This second example is just like the other one. We distribute the 3, and then it's just like this. So not too bad. I think I started kind of writing a little off here. Let me just shift this a little this way. That looks better. Okay, so on this one, we're going to have to do some combining like terms. So let's start by distributing. Well, let me rewrite it first. So I'm going to start by distributing the negative 2. So this goes over a couple things, shows us that we're distributing a negative. So that's going to be negative 18. Then negative 2 times negative 2 is a negative 4m. Remember, 2 negatives make a positive. So if this were to be negative right there, we would make it a positive. But here it's just a negative times a positive, so it's negative. And then on the right side, we have m. So now we have to combine like terms. So what are the like terms here? Now it's kind of confusing. I would think both of these in pink are the like terms just because I'm thinking colors right now. But no, this has an m. This doesn't have an m. So those are not like terms. What about 3 and negative 18? Yes, those are like terms. Why? Because they're both constants. So let me just re-highlight that. So we have 3 and negative 18. So 3 minus 18, let's combine those first. 3 minus 18 is negative 15. And I told you guys to make a habit to move this to the left side. So we're going to do that, even though it would be easier just to add 4m to the other side for once. This is actually the easier way. But I'm going to show you just the way we've been doing, just to be consistent. So I'm going to subtract this m over here, because I want all my variables on the left. I told you guys make a habit of that. Kind of habit I made, and that leaves us with a 0 on the right side because there's nothing left over there. We have m minus m leaves us with nothing over there, but we want to get m by itself, so I'm going to now move this 15 over there. So 0 plus 15 is 15, and then I'm going to go ahead and divide this negative 5 to finish it out, and m is going to equal negative 3. So this example, you'll see the same thing. When you distribute, you're going to have 12 plus 4c plus c equals c plus 4. So you'll see these are like terms. You'll need to combine those, and it should all follow along the same way.